This is a spadefoot toad. It's called that because of this little shovel-like structure on its feet. They're sand burrowers.
A lot of times in science, if you want to understand something, you go find a really extreme example of the phenomenon that you're interested in.
Spadefoots can make drastic changes to their forms and their behaviors in response to the environment. It's a concept called plasticity. With support from the National Science Foundation, David Fenig studies spadefoot tadpoles to better understand the role plasticity plays in evolution.
There are different strategies for achieving the same end, which is propagating one's distinctive characteristics in the next generation.
The tadpoles can come in two very different types, or morphs, omnivores and carnivores.
They're so different that for many, many years, for decades, biologists thought that they were different species.
If the tadpole hatches in a pond rich in shrimp, some will beef up into the carnivore morph. They even eat other tadpoles. But remember, the carnivores and the omnivores are the same species. Once they grow to adulthood, they look the same again.
So we want to know what genes are being turned on and which are being turned off in each of the two morphs.
Fenig says understanding plasticity is important because variation between individuals is what spurs the evolutionary process.
You know, traditionally we just assumed that the reason that individuals vary is because they have different genes. And what we want to know is, well, is there more to variation than just genes?
Turning to the little spadefoot toad for insights into the interplay between genetics and the environment. From This American Land, Gary Stryker for NBC News.